11.2 is going over logarithmic functions and their applications. So with these log functions are literally just another way to write exponential expressions. When we look at these, you're going to be rearranging these terms and rewriting them using exponents. Your base is going to be the little subscript number. The result, or your answer, is going to be the normal number that's next to the little number as your base. And then your exponent is what your equation is equal to. So we're just working in a clockwise rotation here. So if we look at example 1a, we're just writing each log function or log equation as an exponential equation, and each exponential equation as a log equation. For a, we have log 5 of 125 is equal to 3. The good thing to know about these is when you rewrite them, they should make sense, which means they should be giving you a true statement. So this 5, that is your little number, is going to come up. The 125 is going to switch places with the 3, and we're going to have 5 to the power of 3 is equal to 125. So we're just rewriting these. Your little subscript number is going to become your big number, your base. The answer becomes your exponent, and the normal number that's next to your base will become your answer. For example B, we have 6 is equal to log 1/4 x. If you wanted to rewrite this as log 1/4 of x is equal to 6, you can. It'll just make it a little bit easier. This 1/4 is your base, so that's going to become a normal number. The x and the 6 are going to switch places, so the 6 becomes your power, and your x becomes your answer. So we have 1/4 to the power of 6 is equal to x. The next problem that we're going to be working with is example C. We have 1/4 to the power of m is equal to 8. So we're writing this in log function. You want to start by writing the word log. Your base is that 1/2, so that's going to become your subscript number. Your 8 and that m are going to switch places, so that way it's log 1/2 of 8 is equal to m. The whole idea with these, when you're putting them in log form, you want to read them as 1/2 to what power is equal to that 8. So if it's 1/2 to the power of m is equal to 8, you're going to have log 1/2 of 8 is equal to m. For example D, we have 7 is equal to 3 to the power of x. So again, we're going to rewrite this if we need to make it look a little bit better for us. It just would be 3 to the power of x is equal to 7. So we're going to have log 3 is that little number, that subscript number, of 7 is equal to x. So again, the x and the 7 switch places, the 3 becomes a little number. Next, we're going to be evaluating these log expressions. When we're doing that, again, we want to read that base to what power is equal to the big number. So if we look at example 2a, we have log 5 of 25. So this is really asking us 5 to what power is equal to 25. That power is going to be your answer. So 5 to the second power is 25. That 2 is our answer. For example B, we have log 2 of 1/8. So we're going to be rewriting this as 2 to what power is equal to 1/8. Well, if we think about this, we want the reciprocal of 2 to start with, so it would have to be raised to a negative power. So if that was 2 to the negative first power, that's 1/2. How do we get 1/2 to equal 1/8? Well, if we raise 2 to the power of 3, we're going to get 8. So if this is 2 to the negative third power, we have 1/8. So the power here is our answer, which is just that -3. Our next example, C, we have log 1/2 of 4. So again, we're just going to rewrite this as 1/2 to the power of what is equal to 4. Well, we don't want a fraction here, we want a whole number. So this 1/2 is going to have to be multiplied or raised to the power of -1 in order to give us 2. Now, how do we make 2 equal to 4? What power do we raise it to? It would be a 2. So because we have that -1 times that 2, that's going to give us -2. So if we have 1/2 raised to the -2nd power, we're going to get 4. The power is our answer, so that's just the -2. So for all the questions that we've worked on so far, we haven't worked with decimals. The reason why is because when we're working with these logs, it's much easier to work with fractions than it is with decimals. So when we look at example D, we have log 10 of 0.001. That 1 is in the thousandths place. So this is the same exact thing as saying take log 10 of 1 over 1,000. So again, this is just 10 to what power is equal to 1 over 1,000. We know that we're going to have to take the reciprocal of 10 to start with. So if that was raised to the -1, that gives us 1 over 10. How do we make that 1 over 10 into 1 over 1,000? Well, if we raise that 10 to the 3rd power, this would give us the 1,000 that we're looking for. So if we have 10 to the -3rd power, that's going to give us 1 over 1,000. So that -3 is our answer. For example E, we have log 9 of 3. So again, we're going to take 9, raise it to a power, and get us to be that 3. Well, how can we make 9 a smaller number like 3? Well, I know that if I take the square root of 9, that's going to give me 3, and that's the number that I'm looking for. So what power is represented by that square root? You have an index of 2, and it's raised to the 1st power. So if 9 is raised to the power of 1/2, that's going to give us that 3. So our answer for this one is just the 1/2. For the last part of this lesson, we're just evaluating these logarithms. When we do not have a base, it's automatically a 10. So if we look at example A, we're given log 1,000. So this is the same exact thing as saying take log 10 of 1,000. So 10 to what power is 1,000? If we have 10 to the 3rd power, that gives us 1,000. So our answer is just 3. So example B, we have ln times e. ln and e are inverses. ln is just the natural log. With this, these two are still logs. The e is an irrational number, ln is an irrational number. They are reciprocals of one another. So when they are multiplied by one another, raised to the power of each other, they cancel each other out, and you're just left with 1. And for our last example, C, we have log 1/10. So this is the same exact thing as saying we're taking the log 10 of 1/10. So 10 to what power is 1 over 10? Well, if we raise 10 to the -1st power, that's giving us 1 over 10. So our answer is just the -1.